by Nikita, but we're currently sans Nikita, so.
Yeah, he's away at a hockey game tonight,
Is it
so
hockey?
we'll be covering his part.
And Venera were probes launched by the Soviet Union in the 60s, 70s, and 80s to study Venus. Basically, the Cliffs Notes is the first 4 Venera probes were kind of failures. They either didn't launch or didn't make it out of the atmosphere. But Venera's 5 through 15 gathered lots of important data on the atmospheric makeup and general physical properties of Venus, including that you see how the sky on Venus is yellow. That's because of the high sulfur content in their atmosphere, as opposed to oxygen on Earth.
Alright, and then our next 2 missions deal with the Mars rover missions, and I will be starting that off with the Mars Pathfinder missions along with the Sojourner rover. This was launched on December 4th, 1996, and what it did was it carried not only a rover but a little space station with it that landed on Mars on July 4th, 1997. And what this was the second project from the NASA Discovery program, which was this whole initiative to promote more frequent launches by using lower cost spacecraft. And Sojourner landed in the Crisi Planitia region of Mars Eris Vallis. And the mission objectives for it were not only to analyze the atmosphere and climate of Mars, but to study the composition of the Martian rocks and soil. And this landing site was chosen because it is very flat and is filled with these rocks that were believed to have been deposited there by a catastrophic flood. And this is just a fact, but you can see this little base here, that's what the craft landed in, and that is named the Carl Sagan Memorial Station after the late Carl Sagan, who had only passed away a few years before. And here is a bigger replica of what it was. So you can see here you have this platform that encased this whole shell as it came down from the atmosphere onto the surface. This is the main part of the station here. So these wings would fold down, and they have solar panels inside them that would power it, which encompassed the rover here, Sojourner, which could then travel off onto the Martian landscape via these little tracks that it could disembark from the pod from.
So how big is that thing that we see there?
This thing,
Yeah. How big is that Sojourner, that little?
the little rover, this
Yeah.
is very small. It's probably only about 1.5 feet long and about 2 feet high, maybe. But you'll see in the later, compared to the rovers in later missions, it's very, very small. And here are some pictures taken from Sojourner of the Martian landscape. As you can see here, the tracks that come off the pod that I said before. And I know the pictures are kind of a low quality, but I mean, these were taken 21 years ago, sent back to Earth, and then recolored by humans. So I mean, you can't really expect much. But as you can see, very flat landscape, like I said, and all these little rocks, those are believed to have been deposited by a flood, which is pretty crazy considering, that would mean liquid water, which is what we've been trying to find on Mars for so long. And then that brings me to the next one. This is the Spirit rover, otherwise known as the Mars Exploration Rover A. And that landed on Mars on January 4th, 2004. And it landed in a large impact crater named Gusev, which has believed to have been a lake when liquid water was present on the planet. And its mission objectives were to search for iron-containing minerals and then look for environmental clues that could tell us more about what Mars landscape was like when liquid water was present, as well as to assess those environments to see if they're conducive to life.
What did they find, Joe? Did you know?
They did find traces of hydrocarbons, like I said, and that you can see even in the pictures you can see that there was runoff, and you can see where there was water running at some point. So they did find that there was liquid water on Mars at some point.
There are a lot of features from both Spirit and Opportunity, which we're going to hear about next, and orbiters too around Mars, that the only place we see these features on Earth is where water is flowing. And so these guys want to get up close and personal with us.
And the mission was intended to last 90 sols, but instead lasted for 2,208 sols.
What's a soul?
A sol, I'm getting to that. A
Good.
sol is a way to measure time on Mars. And it's not much different than a day. One sol is 24 hours, 39 minutes, and 35 seconds. And unfortunately, on May 1st, 2009, the Spirit rover became stuck in soft soil while exploring a impact crater basin. And it remained there, and attempts were made to maneuver it to kind of get it unstuck. But on January 26, 2010, it was deemed irrecoverably obstructed, which meant that they couldn't get it out. But even though it was stuck there, it still continued to run and conduct experiments as a stationary science platform. And this is just a picture of the rover with all its tools. As you can see, it's much bigger than the previous one, and I don't know if you can see this very well, but this is just a diagram of the Sojourner one that I mentioned before. Spirit, and then an adult male. So the Spirit one is about 3 feet high and 4 feet long, or about the size of a golf cart, whereas this would be like a little remote control car, so to speak. So that's the size difference between these two. And then, unfortunately, communication with the Spirit rover stopped on March 22nd, 2010. And again, attempts were made to regain contact with the rover, but on May 24th, 2011, all of these attempts to gain contact ceased and the mission was deemed complete. And I found this little comic strip here that I thought was pretty interesting, and what it does is it kind of displays very creatively the life cycle of the Spirit rover on Mars. I don't know, can you guys read that?
No.
No? Okay.
I
So
can see it.
you can?
Go ahead and read.
All right, I can just read it out for you. So we start off day 1 of 90, because as I said, the mission was supposed to last 90 sols, which is around 90 days. The Spirit rover thinks 89 days to go. Then we get to day 88 of 90. 2 days until I go home. Day 91 of 90. What the heck? You know, the mission's over by now. You should be going home. Day 103 of 90. Maybe I didn't do a good enough job. Day 127 of 90. Maybe if I do a good enough job, they'll let me come home. Day 857 of 90. I thought I analyzed that rock really well. It's okay. I'll do the next one better. Day 1328 of 90. Sandstorm, power dying, but a good rover would keep going. A good rover like they wanted. Day 1944 of 90. Oh no, I'm stuck. And that's that soft soil in the crater that I mentioned earlier. Did I do a good job? Do I get to come home? Guys? No, it's dead. So that's that. And then I have a little video here. Bobby might have to go run this.
So was the plan that it would just like run out of power and just stay there?
Yeah,
They
that's the
weren't-
plan, but of course it wouldn't have known that. And I'm just gonna skip ahead. This is 6.5 minutes long. I'm gonna skip ahead to about the,
So yeah, they were shooting for 3 months and they got, 6 years.
yeah.
I mean, crazy, crazy success.
So this shows the, how just the landing process of the rover onto Mars.
There's a little bit of atmosphere there so we can use aerobraking.
And aside from the animations of the rover, all of this footage is real-life footage of the team at the Jet Propulsion Laboratory in
We
California.
are now at an altitude of 73 miles, moving at a speed of 12,192 miles per hour. Expected parachute deploy in 5 seconds. 4, 3, 2, 1, mark. We are awaiting confirmation the parachute has deployed. Parachute was ejected. Spacecraft reporting that heat shield has ejection, lander separation event has been detected. Spacecraft reporting lander is separated, moving at a speed of 173 miles per hour. We are near our terminal velocity. Expected retro rocket ignition on my mark. Mark. At this point in time, we should be on the ground. Any signal that we receive from now indicates the vehicle would be alive, on the ground and bouncing.
You know how far they rolled?
I do not know.
Like 3/4 of a mile.
The spacecraft has to survive all the bounces for landing gear success. No signal at the moment. Stand by. Signal strength is currently intermittent. We don't see a signal at the moment. Right.
There have been so many missions that have failed.
And there's that little pod opening that I showed earlier.
Did they get it to be right side up?
They had it, they had basically like a gyroscope in there, and if it wasn't oriented right, it flipped it. There's another animation that shows that. So we've been traveling through space for 7 months. Stretch out a little bit.
The first thing we have to do after we land is open our solar panels to the sun so we'll have some power. This charges up the batteries. After that, we can deploy the camera mast so the rover can see, and deploy the antenna so the rover can talk to us.
We're looking at like anywhere from 7 to 20-minute signal delay, depending on Mars and Picard.
If you'll notice, all the pictures they receive are black and white. The color is added in later by humans based on the chemical composition of what is in the picture. So the orange of the Martian soil is due to the high content of iron oxide and so forth. That was that. It's gonna kick me out, so I'll have to. No, it didn't. Right. Yeah, I did. Alright, and then the Spirit rover was actually a 2-part program by NASA, which involved 2 rovers. Spirit, the Spirit rover, and then its twin rover named Opportunity, which is up next.
Opportunity, or Mars Exploration Rover B, was launched July 7th, 2003, and landed January 5th of 2004, about 2 weeks after Spirit had landed. It landed on Miradani Planum, on Mars, of course, and its mission objective was to take photos of Mars panoramics and examine soil samples and look for evidence of the presence of water, which, what Joe said earlier, it had already seen in how the water had flown over the soil and left it. And it found jarosite, which is a mineral rich in iron and sulfur. Sulfur is one of the building blocks of life, a hydrocarbon, if I'm not mistaken. Among-
No, it's not.
It's not?
No.
Oh. Sulfur's still pretty cool. It's still pretty cool. Either way, it found multiple other minerals that are really interesting. Moving on. Opportunity ceased connection on June 12th of 2018 because it was caught in a sandstorm. And it exceeded its operating plan like Spirit by a lot, which it wasn't expected. And there's still hopes for reestablishing connection, though it's all dependent on the sandstorm. Here we can see a picture of the path Opportunity took starting in 2004 up there by the Eagle Crater, moving down through the years across the land towards the Endeavour Crater in Marathon Valley. And for reference, since not a lot of Americans know kilometers, here's Washington, D.C., and kind of how it traveled the size, if not more, than Washington, D.C. Next up, Curiosity, which was a lot larger than the other rovers, as we saw. Sojourner was very small. The MER rovers were bigger, but this one's about the size of a car, small car. It landed on Aeolus Paulo in the Gale crater on August 6th of 2012. It launched November 26th of 2011. And its goals were to investigate Mars's geology and the whole weather of Mars in general. And it's been extended indefinitely due to its great success. It was there to investigate radiation, amongst other things, to see how the radiation on Mars, cosmic and galactic, would affect potential manned missions to Mars, and they found that it's relatively close to that of the radiation of those on the International Space Station. The picture on the left is a sort of dried up riverbed in which they conducted much of their research and found a lot of the hydrocarbons that they have been finding. On the picture on the right is how far Opportunity has gone thus far. Up there when that picture was taken. And a little fun tidbit about Opportunity: every year it sings itself happy birthday on August 6th. So here we have a pretty complex looking diagram of the multiple tools and instruments on Opportunity, but a few of the notable ones being the mast cams, which basically take panoramic pictures and survey the Mars landscape. Next, the ChemCam, which is a laser-induced kind of spectrographer. It basically simply shoots lasers at the rocks, and depending on the different types of light they produce, it analyzes that to see what minerals and elements they could be. There's the REMS, or Rover Environmental Monitoring System, over yonder, which is kind of like, takes the temperature, barometric pressure, the general weather of Mars, humidity and wind speeds and whatnot. And on the bottom, the APX-S, or Alpha Particle X-ray Spectrometer. Sounds really cool, right? It works in conjunction with the ChemCam by emitting X-rays to help discern other elements in the soil. And these are our citations.
Yeah, they have, on those last three rovers, they have this little head that comes out, and it's got an abrasive tool on it, and so they can pull up to a rock and they can scrape away the surface, and then they can turn it, and it's like a microscope. They can do some spectroscopy, and so they can do all kinds of stuff to look for signs of maybe fossils or look at chemical signatures. Fascinating pieces of equipment.
So there are people who are like driving them like remote control cars every day.
Yes, yep, so from what I understand, the deal is, they send a signal to the robot, based on this picture. This looks like that's, 56 centimeters. So drive forward 56 centimeters. And then, so now we have to wait for that signal to get to the robot, then the robot gets that signal, sends the signal back, I got your signal, I'll let you know when I get there. And so it's, it's gonna be horribly boring. I mean, exciting, but,
Patience.
yes, because these things they don't drive as fast as a remote control car, they're just creeping along. But they did a lot of research on what kind of a wheel and what kind of suspension system to use. So I'm sure they went through millions of dollars of stuff just testing. But I think Curiosity, the last one, can drive on a 45-degree slope, or maybe even more than that, without tipping. I think I read that somewhere. Did you guys come across that at all?
No, but it sounds about right.
I mean, it's tough. It's tough for the kids because, we could have spent 2 hours just talking about this. And so some of these other missions, we could easily spend an hour on it. So to try to pick and choose what you're going to share is, I'm sure that was a little tough on them, but that's all right.
Well, and for funding, if NASA planned on it to be a 90-day mission and it lasted 6 years.
Yeah, so now we got to pay all these people to work all this overtime.
Do we have any questions or comments?
So we did some soft landing on some planets, drove around a little bit. Now we're going to do some landings on some comets and asteroids. And that's pretty cool.
Oh, sorry,
That's okay.
we're good,
Yeah.
maybe, I don't know.
sucks.
I think everyone knows what asteroids look like.
Okay, we have asteroids, like things. Yeah, okay. Enough explanation. Okay, so one of the satellites, I guess you could call it, that went to an asteroid is named Stardust. Its goal was really to capture comet dust and pre-solar interstellar materials. That would be like materials that were formed before the sun actually came to be. So this is an animated picture of what Stardust actually looks like. And this is Comet Wilt 2. It's Wilt, not Wild, because the guy who named it was Swedish or something like that. I'm not Swedish, so I don't know. So basically it went to Comet Wilt 2. It collected samples from the comet, and it returned the samples actually in 2006. And it also collected dust from it in 2004, and it received unchanged materials from the start of our solar system 4.6 billion years ago. I don't know about you, but that's like a long time. Also, one of the most important things that Stardust actually did was it found the building blocks of life in these asteroids, which would be like amino acids and stuff. Now that's really important because that says there could be possible life in places that we don't know yet. So that's pretty freaking cool. Okay, so this picture right here is actually the dust collector on Stardust that would gain the dust and stuff, obviously. This is a picture of Temple 1, and here is, it also went to Anne Frank, which is another comet, but here is comparison. That's Anne Frank in the left. This is Comet Wilt 2, and this is Temple 1. Obviously, Temple 1 is the biggest, but yeah. And then here is a video of its launch and its orbit. Wait, why don't I have sound? Sound?
Yeah, just go ahead and play it.
Oh, okay. Uh-oh. Uh-oh. Oh, okay. Okay.
Back to business.
Wait, do I have my notes on? Okay. 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 Okay.
So just passing into the tail of Anne Frank there.
Mm-hmm. There are actually some images it got of it, right? Comet Wilt 2 right by it.
And then returning the sample to